Okay, question 36 on the final review packet. What we have is a dolphin in seawater that's emitting a sound toward the bottom of the ocean, which is 150 meters below. And then they tell you that the speed of sound in water is the 1530 meters per second. So the question first is asking how much time passes before the dolphin will hear an echo. So we'll write down what we know. The velocity is 1530. And then we have two different distances. We're going to have the distance down, which is 150 meters below. And now because we're trying to ask about the echo, the sound has to come back up. So then we're also going to have a distance of delta x up, which is another 150 meters. So the sound leaves the dolphin's mouth, goes down, hits the ground, comes back up. And that's how we're going to find the total time passing before the dolphin hears the echo. Now velocity in any given medium is constant. So that means that we can calculate it using the constant velocity equation, delta x divided by t. So we do t equals delta x divided by v, and that's going to get us the time up or the time down. So we're going to do this two different times. We're going to do time down, which is going to be distance down divided by speed. Then we're going to do time up, which is going to be distance up divided by speed. So when we go through all of this, we end up taking the 150, we divide it by our speed of 1530, and we do that for both quantities because the distance is the same, the velocity is the same. So technically you can just take the time and solve for one and then you have the other one as well. But they both are 0.098 seconds. Now the question is asking how much time before the dolphin hears the echo. So that's going to be just like projectiles when we found time total of a parabola up and down. We're going to add those two times together because that's going to take the time to go from the dolphin to the floor, then from the floor back to the dolphin. So you end up with a total time of 0.196 seconds till the dolphin hears the echo. And part B is asking for how long it would take this sound wave to travel in the same temperature air. So since we're in air, we have to use the speed of sound in air equation that we have to calculate the velocity at that temperature. So 331 plus 0.6 times the temperature is going to be the equation. So we're going to do that with the temperature of 25 degrees Celsius, ultimately getting us a velocity of 346 meters per second. We're going to use that in our time equation, just like we did previously, to figure out what the time is. Now the question just says, how long would it take for a sound wave to travel this distance in air? Now, by this distance, are they referring to the 150, or are they referring to the 300? It's a little unclear as to what they want, so I'm going to show you both. So since the sound, again, is constant, it's going to travel a one-way distance of 150. So we can use the same equation, delta x divided by v, and get 150 divided by the velocity to ultimately get a value of 0.436 seconds. And that time is the one-way time. So for 150 meters, it's going to take that much time. Now because time up and time down are the same, just like the other one, we can multiply by 2 to get 0.867 seconds for both ways. So if the sound was totally traveling 300, it's going to be 0.867. If it was just 150, it's 0.436.